Hey, we're going to find the x and y intercepts, vertex, and graph of a quadratic function. This particular one is f of x equals 3x squared plus 12x plus 5. And the first thing we can do is find the y-intercept. And remember that y-intercepts come for when you let x equal 0. So basically plugging 0 in for x. And if we do that into our function, everything goes away from the except for the 5. So f of 0 equals 0 plus 5, which is 5. So our our y-intercept is 0, 5. Let's highlight that so we'll keep it close by. Okay. Next thing let's find the x-intercepts. And that's when your function or your y equals 0, and y is the same thing as your f of x. So we got to figure out what x's will make this thing 0. So we'll set it equal to 0. So 0 equals 3x squared plus 12x plus 5, which is a quadratic equation that we can try and solve by factoring. I'm not sure if it factors, but let's see. We can try that with two things that multiply together to give you a times c, which will be 15, and add up to b, which is 12. Looking at that, I'm trying to think. I can't think of two numbers that works for. So maybe the quadratic formula is a better bet. So I'm just going to knock this out and go with an a of 3, a b of 12, and a c of 5. So let's see. That would give us an x of negative b, so negative 12, plus or minus the square root of b squared, which is 144, minus 4ac. And 4 times 15 is 60. That would be all over 2a, which is 6. So we're down to negative 12 plus or minus the square root of 64, which is 8. That would be over 6. So that gives me two answers basically. Negative 12 plus 8 over 6 would be negative 4 over 6, which is negative 2/3. And negative 12 minus 8 would be negative 20 over 6, which I believe gives me negative 10/3. So those two x-intercepts would be negative 2/3, 0, and negative 10/3, 0. So let's also highlight those. So we didn't get nice pretty answers, although for some reason it usually feels like we should be able to factor something in this form, but these decimals or these fractions will work out fine when we go to graph them. The last thing we need to come up with, if we haven't done anything wrong, is the vertex. Okay, and remember that's where we let x be negative b over 2a, so there is some value in identifying your ABC. But that would be negative b, so that would be negative 12 all over 2a, so that would be over 3 times 2, so that would be 6. So the x part of the vertex is negative 2. So then we have to plug negative 2 in to get the y. So I'm going to plug negative 2 into my original function. 3 times negative 2 squared would be 3 times 4, so that would be 12. Plus 12 times negative 2, that would be minus 24 plus 5. So I got negative 12 plus 5, so it seems like negative 7. And we'll see if that works out here in a moment. So I'm just trying to make sure negative 12 plus 5, it feels right. So that's my vertex. So let's come over to the graph. And let's put the things we have here. Negative 2, negative 7 on the graph is, whoops, guess that's not going to hurt, is down here. And that should be the middle of my graph if everything works out. Okay, so that means it's going to be a mirror image on the left and the right. Now the other things I have is a 0, 5, which is up here, which is enough to kind of make a U shape, but let's try and be a little bit better. So my x-intercepts are negative 2/3. That's not quite at negative 1. And then negative 10/3 is a little bit more than negative 3. So 1, 2, 3. So right about in here. So this is not going to look too well when I try and graph it by hand, but it'll be a U shape coming up on this side, curving around, and a U shape coming up on the other side through all those points. So it should be symmetrical around that x equals negative 2 vertex line. And there we have it. All right. Thank you.